In September 1977, a historic day was marked for humanity when NASA's Voyager 1 spacecraft launched from Cape Canaveral, Florida. As part of the Voyager program, which also included its sister craft, the Voyager 2, the main objective was to study the outer solar system, which included close-up studies of Jupiter and Saturn, Saturn's rings, and the larger moons of the two planets. To accomplish their two-planet mission, both Voyager spacecraft were equipped with a toolbox of television cameras, infrared and ultraviolet sensors, and various other instruments with a lifespan projection of 5 years. Designed to take advantage of a rare geometric arrangement of the outer planets in the late 1970s and the 1980s, an initial 4-planet tour was downgraded to a 2-planet mission as it was deemed to be more cost-efficient. Before launch, it was recognized that both Voyager craft would fly out of the solar system, so NASA authorized the production of 2 audio recordings, known as the Golden Records, to be placed on board. These audio records included sounds ranging from whale calls to popular music, as well as spoken languages from across the world. By 1979, the Voyager 1 made its first approach, an encounter with Jupiter on March 5th, when it came within 174,000 miles of the turbulent cloud tops of the solar system's largest planet. Although astronomers had studied Jupiter through telescopes on Earth for centuries, scientists were surprised by many of the Voyager findings. It took some spectacular shots of the famous Great Red Spot, a perpetual storm that's large enough to engulf 3 Earths, and discovered volcanic activity on Io, Jupiter's innermost moon. It was the first time that active volcanoes had been discovered anywhere else in the solar system. Like the Pioneer spacecraft before it, Voyager's look at Jupiter's moons revealed them to be active worlds of their own. After this approach, it was then time to aim for the next planet on the mission, Saturn. The Voyager 1 and 2 Saturn flybys occurred 9 months apart, with Voyager 1 flying within 40,000 miles of the planet's cloud tops in 1980. Although this would be Voyager 1's final encounter with one of our solar system's planets, Voyager 2 would go on to have further encounters with ice giants Uranus and Neptune. As one of our solar system's most picturesque planets, ringed Saturn turned out to be full of surprises. One of Voyager 1's targets was the F ring, which is the outermost of Saturn's famous rings. Voyager's higher resolution camera even spotted 2 new moons, Prometheus and Pandora, whose orbits kept the degree in the F ring in a defined orbit. One sight which continued to puzzle astronomers was from the moon Titan. Close-up pictures of the moon showed nothing but an orange haze, leading to years of speculation about how things could look underneath. It wouldn't be until the mid-2000s that humanity would send the probe Huygens into the haze. With Voyager 1's primary mission over, the focus then shifted on tracking the spacecraft as it sped out of the solar system. One of the spacecraft's most memorable moments came around a decade later, on February 14, 1990, when famed astronomer and author Carl Sagan requested NASA to turn Voyager 1's camera around and take one last photograph of Earth across the great expanse of space. From a record distance of 3.7 billion miles, the jaw-dropping photograph of our planet would be famously known as Pale Blue Dot. On February 17, 1998, Voyager 1 reached a distance of just over 6.4 billion miles from Earth and overtook Pioneer 10 as the most distant spacecraft from Earth. Voyager 1 continued its mission into the expanse of space, and by August 2012, it was confirmed that it had been the first spacecraft to cross the heliopause, which marked its potential departure from the solar system. As of March 2020, Voyager 1 is measured to be approximately 13.8 billion miles from Earth. Since flying past the solar system's boundary into interstellar space, Voyager 1 sent back valuable information about conditions in this zone of the universe. Its discoveries included showing that cosmic radiation is very intense, and demonstrating how charged particles from the sun interact with those of other stars. By 2025, it's expected that Voyager 1 will no longer be able to power any of its instruments, although, as it continues to leave our solar system behind, the spacecraft will streak towards its next big encounter in 40,000 years, when it comes within 1.6 light years of a star called Gliese 445, which lies 17.6 light years from Earth.